With IPv4 variable length subnet masks, the whole reason we do it is to conserve those addresses because there's only so many in that global pool. With IPv6, since there are so many addresses total, we don't need to be as thrifty with them. So you can see right here, here are some example IPv6 addresses starting with that usual 2001, 0db8, ACAD, and then notice what's happening in this fourth hextet. We're breaking it down just one number at a time. So we go 0000, and then the next one is 0001, 2, 3, and so on until we get to 9. But remember, we're in hexadecimal, so now it goes to A, B, C, etc. So breaking up this pi is a little different than the IPv4 pi. So with IPv4, remember we had our pi and we could only ever cut pieces in half, like so. Now the IPv6 pi is considerably larger, but rather than cut it in half, we just cut one slice. So that would be 0000, 0001, 0002, and so forth. And if we were to cut this all up, because what we're working with is a 16-bit section in a single hextet, we would end up with 65,536 pieces of pi. So what we do is now all of these pieces are broken out into exactly the same size. Let's look at that another way. So if we have an address like 2001 0db8 ACAD 0000, and then we have our single addresses under here like that, and then our next address might be that, and so on. What we're doing is creating a huge number of addresses here, because if all of these change, we have some number of quintillion addresses. So rather than subnet because we want to conserve addresses, instead we subnet so that we get simply a better organizational tool. So let's say this is one customer, that they get essentially that. They get all of the addresses to the right of this address. The next customer now gets this one, and the next one gets this one, and the next one gets this one. And each of those customers ends up with quintillions of addresses at their disposal. So now the subnetting, we no longer have to cut in half, cut in half, cut in half. We simply increment. Here's a new network, here's a new network, here's a new network. And each of them is giant.